Now, I'm not a scientist and I have no credentials whatsoever. But my understanding of the Big Bang Theory explains how the universe expanded from a single point. The Big Bang occurred 13.7 to 14 billion years ago. All the matter, energy, and light were all compacted into an infinitely dense point. The universe then expanded tremendously. As the seconds passed, this condensed energy was spread out, and all the forces such as gravity came into existence. Around 300,000 years after the Big Bang occurred, the universe was abundant with floating particles. These particles then slowly came to each other. The most simplest elements came into existence. Most found was hydrogen with one proton and helium with two protons. The different atoms were able to form, and then these particles became more and more condensed. Soon matter was formed. The early stars were made up of very simple elements, so they had very short lifespans of only millions of years. But the nuclear fusion in the cores of these early stars slowly created heavy elements, which, when the stars died, would become part of a new star. These stars were created in small groups and attracted other stars. These stars were grouped in irregular shapes. Then the different shapes merged to form the first galaxies. Then, as more galaxies formed, they became grouped into galaxy clusters, and then these clusters were contained into superclusters. Today, scientists know about a force called dark energy. Dark energy acts like an anti-gravity and does the opposite of gravity. Dark energy is currently the cause of the expansion of the universe. The universe is expanding at an accelerating rate today. With the discovery of dark energy, many scientists now believe that the universe will continue to expand forever and all of the matter and energy in the universe will eventually decay within a trillion years. Many people believe that something cannot come from nothing, and in order for something to come from nothing, it must involve divine intervention. Now, according to quantum theory, something can come from nothing. The explanation of why that happens has not yet been formed, and it happens all the time, and it can be demonstrated experimentally. Vertical particles come into existence spontaneously. They don't last, but during their brief existence they have measurable effects. But it is admittedly a bit of a stretch to compare the appearance of an electron with the mass of the universe. Still, the Big Bang Theory explains a lot of things that are otherwise unexplainable. Quoted from Stephen Hawking's book, A Brief History of Time.
We are not the center of the universe. I explained the magnificence of the light year in my last video, and that a light second is approximately 186,000 miles or 300,000 kilometers per second. Using our fastest space shuttle with current 2011 technology, it would take us 23 years to get to Pluto. It would take about 81,000 years to reach the closest star besides the Sun, Proxima Centauri. Because of vast distances in space, that is why we use the light year. The Andromeda galaxy is rounded to about 2 million light years away. This is our closest galaxy to us. So imagine how far it would be to another galaxy. It would take a space shuttle about 81 billion years to reach the Andromeda galaxy. The Earth itself is not even that old. Therefore, the light that we see from the Andromeda galaxy today left the galaxy 2 million years ago. That is the beautiful thing about space. Things are so far away that you are literally looking into the past when you gaze up at the stars. The farther out our telescopes go into the universe, the further into the past we can see. A great example of this would be the Hubble Ultra Deep Field. It is a picture taken from a speck of sky that is the width of a small dime 85 feet away from you. This was taken in 1995. It is made up of 342 different exposures during a 10-day period. The Hubble Ultra Deep Field is said to be an image of about 10,000 different galaxies and various stages of formation. The light that we see from these galaxies is about 10 billion years old. We are looking 10 billion years into the past. Of course, What we are seeing in these images is not what currently is. We are seeing these galaxies from what they looked like 10 billion years ago. This is not a representation of what they look like now. We can see galaxies that were beginning to form together 10 billion years ago, but now they are probably already fully formed. NASA's Wilkinson Microwave Anisotropy probe captured a new portrait, one that could be considered more important than the Hubble Ultra Deep Field. It shows what is said to be the afterglow of the Big Bang, which is oftentimes referred to as the cosmic microwave background. The light from this image is said to have taken 13 billion years to reach us. Of course, this cannot be seen with the naked eye. For more information about this, I suggest visiting the link below by NASA to try and understand the data collected from this finding. Does this mean that the Big Bang is 100% true? Not necessarily. While it is highly probable, it still has not been scientifically proven, and we are still struggling to find out answers regarding the subject. With some people, they assume that scientists are saying that nothing came from nothing, which is a complete misunderstanding of what they have gathered thus far. The theory itself is constantly being revised. I will not talk about all of the current supposed evidence, data, and research for the Big Bang here. There are many books on the subject, and many scientists have written papers on the matter. The fact that this theory is constantly being revised is not a reflection of science's failed attempts to understand how we began, but it is a reflection of intellectual honesty. Nothing can be certain at this moment in time. If scientists gain enough information to discredit this probable theory, they would gladly reject it along with further investigation. I do not have faith in the Big Bang. I see it as a probable theory that could have happened, and there is tons of information and research to support that. However, I do not know for sure. We do not know for sure. And I would rather admit not knowing for sure than admitting I know for sure, and have the contents of that admission be something that can most definitely not be proven with any sort of valid evidence. After writing the contents of this video, I could already hear the arguments against all of this in my head. After feeling a wave of wanting to go through those arguments and debunk them, I realized that even if I did that, it wouldn't get past the previously learned or obtained biases from the individuals who would choose to argue with me. I can only attempt to raise people's consciousness about the magnificence of currently observed phenomena and admit to you proudly that no, we do not know everything. That is what makes science interesting. If we did know where everything came from and why, there would be no need to explore and ask questions. That, to me, would be a boring existence.